Let's start creating a milling operation. So in the milling operation, we have to first create part, the part to be milled, okay, and uncheck the default template. Okay, choose the part file and the template. Let's take it this one. Okay, let's extrude basically and this template. Let's extrude. Before that, we should set the managers and select the working directory, otherwise it will go somewhere else. Let's keep it here. Let's choose new folder. That should be exercise number 04 in our advanced manufacturing technology. Okay, this part will have an extrude and it's a planer, plate, face milling and profile milling. So let's create the face first with the center rectangle of 100 by 100. This one should be 100 and this one also 100. Okay, let's extrude it by at least 4 mm. Okay, that's it. Let's see it. And on the top of this surface, let's create one more extrude with a slab tab sour slot. Okay, let's go to that sketch view and draw one more center rectangle of this one is some 90 by 90. Okay, otherwise let us keep it some 80 by 80. Okay, and in this let us create a chamfer. In this area let's create a chamfer. Okay, let's constrain this dimension by by 10 d1 and 10 d2. Okay, the next stuff is this one also 80. Let's make it strong by giving the dimension so that it will be looking navy blue. Okay, let's start this one also. Let's make it strong so that it won't change with other features, other referenced features. Okay, and there is one more arc here. Let's take center point arc from this point to this point. Okay, let's give its radius 15 mm. Okay, and delete the trigger segment. Okay, and this needs to be thickened. To thicken this profile, let's offset it by selecting rule-based complete loop. Okay, and this one, let's keep it some 10 mm. Okay, let's keep it like that. This one, let's keep it for 6 mm height. And this is okay. Let's try to understand the basic milling operation and create the G code and M code CNC program in this tutorial. Okay, part is ready. This is the finished parts. Let's give this radius also, otherwise it won't. Even if you machine it without giving radius also, it will generate the error. It's not the error, but in fact it will be machined like a fillet only, because the tool cannot generate sharp corners because of the tip or tool bit radius. Okay, this needs to be done for tangency, and otherwise the tool sometimes will get struck and broken into pieces. For that, we should not keep anywhere the sharp corners. We have to give some radius everywhere to reduce the sharp turning of the tool. The tool will estimate automatically, won't go here and stuck it, but anyway, it will jump. So it will create only the profile. But let's make sure that this is the finished part. We are going to get with the fillets everywhere. Okay, this all as a requirement for manufacturing. So this is one of the stuffs that we should learn from manufacturing point of view. That's why this is called design your part for manufacturability. That's why it is called DFM. Okay, now let's save this part and go to new and create a manufacturing and NC assembly. Let's create a milling operation using CNC milling machine. Okay, and uncheck this use default template and select MMS manufacturing and numerical control absolute access system. Okay, let's assemble the reference model, and this part is what we have created, and let us constrain it at its default position so that it will become fully constrained. Let's give OK. Okay, now let's hide this coordinate system. Let's see that, and okay, yeah, no, let's take this and hide this coordinate system. Let's see that. Yes, x in the spindle axis system, the spindle axis center, and z upward and y towards us. Okay, let's keep it like that. This one is fine for me. Let's save it. Let's create an automatic workpiece, not a deal. Okay, this one takes the parts coordinate system. Let's take the assembly coordinate system. Okay, this one is milling operation and overall dimension is 100 by 100 by 10 mm. Okay, let's start. Keep it as it is. Okay, now we have to select a work center. Now we are going to do the milling operation. And in this milling operation, we are going to use a tool. So tool tip dia, let's keep it 6 mm so that it will take time, but it will give us a good roughing operation. We are going to just give the rough milling. Okay, restart. The software will create by default. Will do those application, those calculations. Now this for this one, let's select this axis system. That's okay, good to go. Okay, I think so. Okay, let's see. Okay, and select a plane. The reference is this one. Let's take an offset of 5 mm. It goes up. No, where is that offset? Tolerance 5 mm, so that it won't hit. The tool won't hit. It should sometimes, the plane should go upward. Okay, no problem. Let's keep 1 mm minimum. Okay, tolerance. Let's keep 0.5 mm. It will take. Okay. Now you see the new menu has come, milling. In this milling, let's create a mill window. This one also will be created automatically. Window plane is this one. Okay, and it would be a slot. This one you see, and that one. This and all sketch, the outline sketch. That's how the tool will travel. Okay, for the outer profile, we'll use this sketch, and for the face milling of the center area, you take this profile. Okay, that's all. Now we are going to create a roughing operation using the tool one we have created, and let's close it. That's it. Let's see that tool path. Let's play the tool path. The tool path. How the tool will move. This was the real-time simulation. Okay. Now you see the tool how it's taking the material out from this part. Okay. Close it, and we can see the real-time material removal simulation. The real-time material removal simulation will help us to fine-tune that DFMs most of the time. This is what our raw material 100 by 100 into 10 mm thickness plate. Okay, let's just play that simulation. Okay, let's keep this here and play it. See that the material, how the outer profile is milled out, the material removal cycle, and after that it will enter and do the face milling. This is a rough operation. It would be having n number of stacked up lines, layer by layer lines, and the finish operation will be done after this to give a smooth surface. Okay, this simulation is going to happen in our physical CNC machine, which has a Fanuc control board. Okay, this is what the milling operation. This is our 10th exercise in manufacturing technology 2. Okay, we can make it faster also. Okay, so that we can understand the basics. See, even if you don't give fillet here, it will take the similar pattern because it's a rough operation. Tool cannot stuck there. But anyway, we have given already. Close it. Let's close this material removal and go to the manufacturing and let's create a CNC program. So milling operation, NCC is rough milling operation, and file, MCD file, done. Let's save this cutter location file, NCL file. Okay, and after that, done. Okay, now the list of machines will come. This one is for milling operation. See milling version. Okay, these are all default machine given by PTC Creo Parametric. Let's close this. That's it. We have done the CNC program. We can see our CNC program code. It's not just like that. You are seeing it in your textbook. They will just highlight the points 1, 2, 3, 4, 5, 6, 7, 8. That's what the basic profile path the tool will follow, but not in actual condition. It should follow in interpolation, leading interpolation, one by one, step by step. It will remove the material. That we can see. Even you can, if you can read the cutter location file, it will give in transcripts what is that it's doing. Let us go to our file, the fourth exercise file. In this, the CNC program is created in the tab file. See the tab file. This will work. This is G71 is material removal cycle. The G71 is material removal cycle. So this will come with our milling operation. Okay, and restore linear interpolation. Sorry, and circular interpolation, clockwise, linear, circular interpolation, and circular interpolation, anti-clockwise, restore. Okay, and that particular cycle that is mentioned in the top will continue till the end of the program. It's non-modal type code, so it will end when the program ends. See, these many things are going to happen in your milling machine. And if you see that cutter location file, you can read the actual stuffs that's happening. Now you see spindle RPM, clockwise direction, that is 7,957 RPM, revolutions per minute. Go to this position, XYZ position, and feed rate is mm per minute, this many per minute, and go to this, and all are transcripts translated to our human understanding circle. Okay, and it starts with the code. Where is that? The cutter, since it's a cutter, the cut geometry type, output on center, and the milling operation. As long as this milling operation is concerning and cutter is placed in, that means that conveys of G71 cycle. G71 cycle is material removal cycle. Let us understand the basics of using a software to create the CNC program and make and prepare the part in this video, and each and every individual M and G code we will study in detail in the further. Okay, thank you for watching this video.